Hello all. In this video, I am going to explain you the concepts of one of the most important pillars of object-oriented programming, which is composition. Composition, in simple terms, I can say that has a relationship between two classes or two components of our programs. I can say that if there are two components A and B, and if A contains B, then A and B are related to as composition relations. In our programming journey, we have encountered some kind of scenarios where we must decide which one to use, whether inheritance or composition. That is, whether is a relationship or has a relationship. When we are trying to make use of inheritance, we might encounter few of the scenarios where we must be handling complex tree structures that are being generated by inheritance, which are very difficult to maintain, and there are few of the programming languages which lack multi-inheritance concepts. And there's also an issue of tight coupling between the classes. There's no guarantee that every pair of classes must be having an is-a relationship. In the real time, we mostly see a has-a relationship over a is-a relationship. So in this video, I'm going to show you, with the help of Kotlin, how Kotlin provides an easy methodology for us to achieve the composition with the help of the keyword called by. I'm right now in play.kotlinlang.org, and with this online editor tool, I'm going to explain how I can achieve the composition and how I can convert the simple composition with the usage of the by keyword, which is provided by Kotlin by default. Okay, so let us start with an example. I have an interface iLaptop that has the properties name, and I have an interface to define the structure of CPU called iCPU that has the properties name, the number of cores it has, the hyperthreading, whether it's enabled or disabled, along with the function that I want to implement, that is, get all the specs of this particular CPU. I'm going to implement a class CPU that is going to extend the interface iCPU. In the object-oriented nomenclature, I must say, CPU implementing iCPU. I'm going to override all the properties that are present in iCPU in the primary constructor, and I'm going to override the function getSpecs with a simple implementation that is returning the concatenated string of the properties name, cores, and hyperthreading. Now I implemented a class Dell that is going to extend the interface iLaptop with name being overridden, and I'm also passing an extra parameter called CPU specs. So this Dell laptop has this particular kind of CPU specs. I'll implement the main function where I'm going to instantiate an object of the Dell laptop, passing the name as Inspiron and passing the CPU specs as Intel 8 and hyperthreading to true. This means I'm here achieving the concept of composition by saying that my laptop has the properties of CPU. And with this print line, I'm going to get the specifications of my Dell laptop. If I run, I get my specifications in the form of a string. And here comes the special part. Will I be able to get the specifications of my laptop without having an intermediary variable called CPU specs? If I directly remove the CPU specs, I would say that I am getting an error, unresolved reference to get specs. So Kotlin by default supports the concept of delegation, which is a syntactic sugar of the composition. I must say iCPU delegated by the variable CPU specs. So if there's any function that is present in the interface iCPU and which is being called by this object Dell laptop, the call must be delegated from the object L to the object CPU specs. And this is how we can tell Kotlin with the help of this particular implementation with by keyword. And if I run this, I get the output. So instead of an intermediary variable CPU specs, the end user doesn't know what is the intermediary variable, but still he can access the properties and functions of the class which has a relationship with the other classes. For suppose I want to implement a Dell laptop with a constant CPU specifications, something like this. So here I'm going to initiate an object, and I don't want my CPU specs to be a separate variable in my Dell laptop. So I'll be removing this property from my Dell laptop and delegating the iCPU calls to this particular object of CPU. Hooray, it still works. So the previous implementation and this implementation are similar, just the way that we have removed one more dependency on the extra intermediary variable. In this way, class delegation works in Kotlin. Now I would like to tell you an example on property delegation. Suppose we have a class laptop and that has a name that is initialized to some laptop 1, and I'm going to delegate the getters and setters of this particular property through another property called copy name. That is also of type string, and I'm using the keyword by with a reference operator called two semicolons followed by the property name that you are going to delegate the calls. So I'm going to print the name of this particular laptop. So I got laptop 1. What if I try to change the name of this particular laptop with the help of copy name? And I'm going to print the l dot name again. So here I see, even though I changed the name in copy name property, the value of this property name also got changed. So the getters and setters of copy name that I am invoking here are internally setting the value of this particular property name. So I can say the getters and setters of this are delegated through this property. In this way, class properties and class delegation and property delegation works with a syntactic sugar of the keyword by in Kotlin. Thank you.